This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you.
Rules. 1. All non-zero digits are significant. 2. Interior zeros are significant. 3. Leading zeros are not significant. 4. Trailing zeros. A. After a decimal point are always significant. B. Before an implied decimal point are ambiguous and should be avoided by using scientific notation. Reasons for these rules. 1. If a digit in a number is non-zero, that digit exists in real life and was measured. 2. All interior zeros are significant because they are important so that all non-zeros can exist. i.e., 108 is a real number, and removing the zero as non-significant would mean counting past 99 wouldn't make sense. 3. Leading zeros never mean anything, and therefore cannot be significant. Think of a digital clock, e.g., 0307. You never read the leading zero. It's not 0307. You do read the interior zero. 0.003 is the same as writing 0003. It's just unnecessary. 4. A decimal point means we are being exact. That decimal point only exists because we are taking an exact measurement, so all trailing zeros after a decimal point is an interior zero. We just don't always know what the non-zero digits following them are. An implied decimal point means we expect a number ends with a decimal point, i.e., 1,200 things can have a decimal point, 1,200 decimal 0, but 1.2 times 10 to the 3 is better. Rules for calculations. 1. In multiplication and division, the result carries the same number of significant figures as the factor with the fewest significant figures. 2. In addition and subtraction, the result carries the same number of decimal places as the factor with the fewest decimal places. 3. Only round the final answer. Keep all the digits as calculated by the calculator and write the full final answer, then and only then round the answer. 4. When rounding to the correct number of significant figures or decimal places, round down if the last or leftmost digit dropped is 4 or less. Round up if the last or leftmost digit dropped is 5 or more. Reasons for these rules. 1. The answer to why this rule exists starts by asking the question, why are we multiplying or dividing in the first place? The answer to that question is that we want an exact number for some property of a real-life object, e.g., density. Density can be found by taking the measured mass of the object and dividing by the geometric volume of the object. This means we need a weighing scale and a ruler. Therefore, to be as exact as possible, we need to reduce the most exact measurement to the same level as the least exact measurement. If the scale can measure 5 significant, real-life measured numbers, but the ruler can only measure 2 significant numbers, we can only be as exact as the ruler. Anything more would be imaginary. 2. The same is true of addition and subtraction. The purpose of adding and subtracting is that we are looking for an exact, real-life measured answer. Multiplication and division are done when the measuring devices are totally different, i.e., mass, weight, versus radius, length. So what matters is the number of available significant figures. Addition and subtraction are used when the measuring device is the same, i.e., adding length to another length, subtracting weight from a different weight. In this case, then, what matters is the number of decimal places. Say you buy a bag of peas, and the factory that bagged them has a scale that can measure 5 decimal places beyond the decimal point, a very exact measurement. But at your house, the scale can only measure 2 decimal places beyond the decimal point. So if you want to know how much weight is left in the bag after making a dinner with a side of peas, you can only be as exact as 2 decimal places. This is why in addition and subtraction, the final answer is the same as the number with the fewest decimal places. 3. This rule is quite simple. If the goal is to be as exact as possible, only the final exact number can be rounded. Round too early, and the final answer is not the exact answer, but just an estimated answer. 4. This rule preserves exactness as best as it can. If a number is closer to a higher number than it is to a lower number, and yet you round down, you lost real-life stuff, and therefore lost exactness. And vice versa. If you round up a number that is closer to a lower number than it is to a higher number, then you just created imaginary stuff. Both cases would be inexact and would defeat the purpose of the procedure. Dimensional analysis. The purpose of dimensional analysis is to convert the units of an equation, not the value of an equation. For example, 100 kilometers per hour is the exact same speed as 62.14 miles per hour. The car traveling that speed did not slow down or speed up. The only thing that changes was the unit that we use to describe its motion. To change units without changing the value/measurement, the original units must be multiplied by what is called a dimensionless factor, which means a factor which is equal to 1. For example, 100 kilometers equals 62.14 miles, which can become either 100 kilometers divided by 62.14 miles equals 1, or 62.14 miles divided by 100 kilometers equals 1. Further, to change the units, the dimensionless factor needs to cancel the original unit by being on the opposite side of the dividing line. For example, to change 62.14 miles per hour into meters per second in steps. 62.14 miles over 1 hour times 100 kilometers over 62.14 miles. The 62.14 miles cancel out and we would get 100 kilometers over 1 hour. Next step. 100 kilometers per 1 hour times 1,000 meters over 1 kilometer equals 100,000 meters per 1 hour. Next step. 100,000 meters per 1 hour times 1 hour over 3,600 seconds equals 27.77 repeating meters per second. Done all at once, we would get 62.14 miles per hour times 100 kilometers per 62.14 miles times 1,000 meters per 1 kilometer times 1 hour per 3,600 seconds, equals 27.77 repeating meters per second. 27.77 repeating meters per second is still the exact same speed as 62.14 miles per hour. Nothing but the units used changed. That's the purpose of dimensional analysis.
If you would like to support Existence University, you can visit us at our Patreon at patreon.com/youexist. Or you can now go to the Existence University website at existenceuniversity.com. Future products will be coming to the market, but in the meantime, you can contribute to Existence University at existenceuniversity.com through our donate page.